Hey everyone, last video we proved the first important limit. Today we'll be practicing some problems. Before we start practicing any limits problems that's related to the first important limit, I will actually write down the limit up here so we can refer to it later. Okay, let's practice our first problem. Alright, so how do we apply the first important limit that we know to this problem? Right, some of you might say that this is equal to 1. That is not right, because the term after the sign, right, the term after the sign, the x, that must be the same thing in the denominator in order for the limit to be true. So that means that we want the 4x to be in the denominator. So we times 1 over 4, okay? And then that would just become sine 4x over 4x. Okay, now you have it, but there's a problem. Since we times a 1 over 4 here, we must times a 4 to the limit so that the limit holds true. And then at the end, we'll end up with this. And that would look something like this. So now this looks familiar, right? We have 4x, sine of 4x in the numerator, and we have 4x in the denominator. And then x is just equal to 4x, right? So we can just use what we know, right? And then using the limit property here, we know that 4 times the limit value, right? And that's basically 4 times 1, which is equal to 4. And that's your final answer. Alright, let's do another type of problem, which is a little different from what we did for the first question, but let's try it. The limit of sine of 3x over tangent of 7x as x approaches 0. At a first glance, you'll know that it's a little different from the first important limit because you have sine 3x on the top and tangent 7x on the bottom. So how do we do this one? Well, let me tell you, we can do it like this way. Let me just write it down. Okay, now does this look familiar? Sine 3x over 3x. We have both 3x, right, on the top and the bottom. Here we have tangent 7x over 7x. Although it's not exactly the same as sine x over x, but, pretty much the same, we can still use that kind of equation to help us solve the problem. And you know that right now we have a 3x on the bottom. That means that we have to time 3x, okay? So that the limit still holds true. And the same thing with 7x. So after that step, I could do this. What I could do is this, okay? Let's see. I could add the limit symbol before each term, okay? I will show you. Okay, so I've distributed the limit sign, right? The limit to both the numerator and denominator. 我把这个极限的它的这个符号分配给了这个分子和分母，对吧？那么接下来就更容易了。为什么呢？我们看是不是很熟悉啊？对吧？ Limit of sine 3x over 3x as x approaches 0， 这个等于1。然后呢，利用我们第一个重要极限呢，我们也可以说呢 limit of tangent 7x 除以 7x 当 x 趋近0时呢，也是等于1。所以呢，这个等于1，这个也等于1，对吧？最后是不是就等于当 x 趋近于0时 3x 除以 7x 的极限 然后呢，我们可以继续化简，是不是就等于3:7的极限？那我们知道极限这个后面呢，极限整个这一块呢，后面如果跟一个常数的话呢，那么这个极限呢就是常数本身，它这个极限值就是常数本身，所以呢这道题的答案就是3/7。OK。好的，所以今天呢我们就练了一下这个第一重要极限的应用，我们下期视频再见，拜拜。